Let's talk about how we formulate active ingredients into a final product and what sorts of ingredients go into them. I'm going to pick the example of a suspension concentrate, also known as a flowable. As we may have seen before, active ingredients are very often not happier in water. They can be extremely hydrophobic and they just don't want to go in. So that's the first obstacle we've got to overcome. We've got to get the active ingredient into water. Now we're going to need some help there, and that help is going to come in the form of surfactants. Now, a surfactant, very simply, is a molecule that has two parts on it, one part that likes oil and one part that likes water, built into the same molecule. And one surfactant we're going to need is a wetting agent. So this is a surfactant that will stick to the active ingredient particles and allow them to go into water. But very often that's not enough, because once they go into water, they're still going to want to stick back together. Remember, they hate being in water, and they're going to do everything they can to avoid the water. So to prevent them from sticking back together, we're going to need another surfactant that's functioning as a dispersant. These very often are polymeric or long molecule surfactants that allow those particles to be separated. If we can find that right combination of wetting agents and dispersants, we can really change the physical properties of the active ingredient, which I'll demonstrate now. So the active ingredient is clearly not happy in water. By adding these surfactants, we can make the active ingredient a little happier in water, as you can see. The AI is going into the water. Now, unfortunately, you see what happens. The active ingredient settles down to the bottom of the jug. And that's because most active ingredients have a higher density than water. And that's going to be a real problem if you're developing a flowable that's going to be in a package, because the active ingredient would all settle to the bottom, possibly hard packing, and you would never get it back up. So to stop the active ingredient from settling out, we're going to need some help in the form of a suspension agent, something to make that formulation thicker or raise the viscosity to keep those particles from wanting to crash down so quickly. Now, a property we try to build into our formulations is known as shear thinning rheology. Now, that's a very fancy way of saying a fluid that's very thick when it's sitting still, but once you go to shake it or move it, it turns into a liquid, which I can demonstrate. So as you can see, this material is very thick. It's basically solid. But when I go to put some energy into it or shake it, it now turns into a liquid that flows. Because the ideal formulation is very, very thick while sitting on the shelf, so the particles aren't settling out. But then when you go to open the cap and shake it and pour it, we want it to flow. And that's what we try to build into our products. Because we have water in this formulation, we have the chance that microbes like fungi and bacteria can actually grow in the packaged product. And that can be very bad because microbes could digest some of the other ingredients. More importantly, our suspension agents. So if the microbes digest that, that's going to allow the active ingredients to settle out. So a preservative is often very important to put into a formulation to stop that from happening. Because we have surfactants present and you're in a spray tank situation where you have water moving and air entrainment, you have the potential to get a lot of foam in that spray tank. And foam is extremely bad because that can actually strip surfactants off your active ingredient particles, and then they're no longer going to be happy in there. So very often we might need to add some kind of an anti-foam system. Now, to show you how important that is, I have an example of two formulations, one with a poor anti-foam system and one with a really good high-quality system. These have been diluted in water, and now we'll shake them up. And very clearly, you can see the difference between the formulations and how important that ingredient can be to minimize foam. Since we are developing a water-based formulation, and we all know what happens to water at 32 degrees, it can be extremely important to build in an antifreeze system. This will allow that formulation to maintain its quality if it happens to be subjected to freezing temperatures or even freeze-thaw cycles. Sometimes we can build adjuvants into a formulation. An adjuvant, very simply, is a compound that allows the active ingredient to work better, allows it to penetrate a leaf cuticle or maybe an insect outer skeleton, and sometimes we can build those directly into formulations. Buffers can be an important ingredient in water-based formulations, and these are used to control the pH. That's especially critical when you have an active ingredient that's very sensitive to pH extremes, because it could cause chemical instability of the active ingredient. For contact fungicides, such as chlorothalonil in our daconil line, rain fastness is extremely important to get the length of control that you expect. That's why we have done a lot of research and development to discover rain-fast technologies that we can build into that formulation so that after application, the deposits remain intact even after irrigation. Obviously, a very important ingredient in a water-based formulation is water. But it's very important to maintain the quality of the water that's going into that formulation, because poor water quality can result in a formulation that's not as robust as you want it to be. So this is why in production, Syngenta maintains the quality of its water to the very highest of standards. One aspect of a suspension concentrate that's very difficult to demonstrate here is particle size. So the active ingredient crystals, as they come out of synthesis, can be fairly large, up to a few millimeters in diameter. And that's a real problem because if you did not reduce that particle size, they could clog your nozzles, they're going to settle out very quickly in the packaged product and even your spray tank. And we even have some evidence that particle size distributions can impact biological efficacy, length of control, and even turf safety for some AIs. So this is why it's important when developing a suspension concentrate that we know what we're doing when we mill the active ingredient. And there's a lot of science behind understanding how active ingredient crystals behave when they're milled, so we know how to mill them properly. So putting this all together, once we have developed the formulation, which by the way takes anywhere from 1 to 3 years depending on that formulation, going through hundreds of different prototypes, we found the right ingredients and we've milled them to the correct particle size, the final formulation would look something like this. So this is an example of Barricade 4FL. So with the help of the formulation, we have taken an active ingredient, like prodiamine, that is extremely hydrophobic and transformed it into a product that you can now add to your spray tank, mix up, and apply. And that's what formulations is all about. Taking the active ingredient, which is essentially useless, and turning it into something that's very useful and user-friendly. It's also very important to realize that after we've developed a formulation that has the robustness we're looking for, we don't stop there. There's an extensive amount of testing that goes on to make sure it's going to be robust in a wide range of different environmental conditions: high temperatures, cold temperatures, cycling temperatures. In addition, we test formulations for biological efficacy, because as we mentioned before, formulation ingredients and even particle size could impact control. So we want to test that to make sure we have the optimized formulation. Finally, we test that formulation on a wide variety of turf grass species, because that formulation could have components in there that cause phytotoxicity. We need to make sure that formulation is going to be safe. We at Syngenta go to great lengths to develop high-performance, quality products so that our customers have the best experience possible when using them. This takes a tremendous amount of resource and scientific expertise.